Boom, here we go. Here are the first 6. Take a look, compare what you got with what I got. Let me explain what I can, where I can. I screwed up one of these this morning when I was cranking them out. And then the student called me out and said that I was wrong, and she gave me an answer. I was wrong, but then the answer that she gave was also wrong. It was an amusing series of events. We were wrong separately, but together. Then figured it out. It was question letter F. F is a tricky one for the 8s times tables.
Is the answer that's up there right?
This is now correct, yes. 6 and 7/8. Dad, did you get something different?
Yeah.
What'd you get?
I got 7 and then 1/8.
You got 7 and 1/8. See, I got 6 and 1/8. So my reasoning is here. Like, I just went through the 8s timetables. After she said I was wrong, and then she gave me her answer, we went and did this. Turns out she was also wrong. So 8 times 6 is 48. 8 times 7 is 56. If your mental math game is not strong, mine was not strong this morning at first block because I was up late watching Hell's Kitchen with my wife. So I was tired. 8 times tables were not there. Take a look at the multiplication table. 8 times 6, 8 times 7. So 55 is going to land between these two values, which means it's going to land between 6 and 7, which means your whole number has to be the 6.
6, 7.
Yeah, 6, 7. So the whole number's got to be the 6. And then 55 minus 48 is 7, gives you the numerator. The 8 stays in the denominator. So 6 and 7/8. This morning I said it was 6 and 1/8 because I thought that 8 times 6 was 54, but it's 9 times 6 is 54. You just want me to say a quick 6, 7? There's your quick 6, 7. And it's now in my video forever memorialized. It'll be on YouTube. If you want to go back to that video, you can be like, just clip that part and just make it your ringtone or something. Do it off, just, yeah, throwing that on there. Okay, next page. I wanted you to do aces on the top 9, which would take you through A, C, E, G, and I. There they are. 1/5, 1/4, 1, 3/8, and a third. And then down at the bottom there, I wanted you to do BDFs. Convert the mixed fractions to improper and simplify. So now we're going into improper, out of mixed. And I wanted BDFs, which would take you through B, D, F, and H. So 9/2, 51/10, 7/3, and 19/3. Comments, questions, concerns on any one of those? Would anyone like me to demonstrate any of those? If you were away and forgotten, or have forgotten, or going once, twice, thrice, okay, sold. Okay, then I wanted you to do aces on this page again, which is A, C, E, G, I, and then, I don't know why it went G, H, and I again, but it would have been this letter down here. Convert the improper to mixed and simplify. So 7 and a third. 4 and 2/3, 14 and 1/3, 1 1/2, 1 and 7/8, and then the bottom one is 12 and 3/10. Is there anything there anyone would like me to demonstrate, discuss, argue with you about? Keeping in mind that I already argued with the first block about this, and between the 23 of them and me, I think we settled on these being the correct answers. There are more of you, though. There's 26 of you, so if we're doing math by democracy, you might win. Okay? Hearing nothing, the next piece that I gave you, or the last piece that I gave you guys, was I wanted you to try this. What is the difference between a 16-ounce brick and a carpenter? For those of you who did it, the pun...
Like one is a pound or something.
One weighs a pound and the other pounds away. This is your answer down here at the bottom. It's funny. 16 ounces, one weighs a pound and the other pounds away because a carpenter hammer on the nails. No? Okay. I appreciate the fake laughter from the back table. Love that. The worst one was the optional. Did anyone do the optional one that I gave you? The Oh, where did it go? This bad boy? Did anyone attempt it and want to see if they got it right? Nobody attempted it. Okay, cool. For those of you who didn't attempt it, write down the answer anyway so that you could go back and verify. Here is the answer. Why did the football coach send in a bunch of second string players? He wanted to tie the game. Boo. So I had a bunch of students in my first block didn't get this. Like they got the answer, but they didn't know what it meant. So if I have to explain so that we can all get the joke together, I will explain, which is where it loses its humor. The second string is the name in sports typically reserved for the players who start the game on the bench, whatever sport that might be. So why did he send in that second string? Because you tie things with string, and so he wanted to tie the game. It's really bad. It's really bad. But that's the pun. Why did the football coach send in a bunch of second string players? He wanted to, and in football especially, if you start the game on the bench in football, typically it means you have room to improve if you are a second string football player, typically. Okay. Here we go. Let us review comparing numbers, shall we? Here we go. Today's lesson looks like this. We're going to compare numbers, and for lots of you, this is going to be parts of this are going to be trivial, and parts of this are going to be a little odd. Especially if, like my first block, there are some stuff that you didn't look at that I definitely thought you had. So we'll find out where we're at with that. So if I asked you to order the following numbers from least or smallest to greatest, biggest, what would the order of that be? Now, what are some ways that you might do this question? Some of you might just crank out the answer in your head. If you were to crank out the answer in your head, what would it be? William. -8. -1. 0. 2. 5. So pro tip, as you're going, what I didn't do but definitely could have, if we're going to crank these things out in order, as you're going, just cross them off. It makes life a lot easier. We don't double count things like -1. If for whatever reason that is just either there's two options here. Either that just doesn't click first time mentally, or I say something ridiculous like, prove it, because I'm going to do that to you all the time. One of the tools that you can use to do this is the number line. We talked about number lines last week. I'm going to get you to do some stuff today where I'm going to say, just give me the answer and justify it. One of the ways that you would justify your answer to a question like this is throwing it down on a number line. So let's recall the rules for number lines. There were 3 things I gave you when we talked about number lines. What is it? If you're making a number line, what should you do? Dea.
Always even out the space in between the numbers.
Yes. I'm just going to condense what you said down into the single word spacing. Even out the space between the numbers you throw down. You betcha. Related to spacing, what was something else we talked about? William. Yeah, you need some sort of anchor value. Could be one of the three numbers. Sorry, it could be one of the 5 numbers that's there. Often your anchor values are what kind of values? I mean, given these 5, what is an example of a number you could use to anchor your number line? William. What would you choose if I asked you to make a number line here?
0.
Okay, 0 would be a number of those 5 you could use to anchor. Would anyone use a different value? All of you would use 0 and just call it good?
Minus.
Which one?
No.
Nope. You take it back.
Yeah.
Okay. The middle value is often a good one. Same way. The extremes, the biggest, the obviously largest, or the obviously smallest, also good numbers to pick. as anchors for your number line, and you can spread out from there. What's the other way we talked about number lines? How are number lines read?
Left, right?
Left to right. So on the left side, left to right, on the left side, we want the smallest or most negative. That's my shorthand for negative. A minus sign with the letters VE after it. And on the right, we want the biggest or most positive, a plus sign, VE. So let's do this. If I'm going to anchor this at 0, if 0 is going smack in the middle, let's space these things out, shall we? We're going to go up to 5 and down to 8. Negative 8. 1, 2, 3, 4, 5. Place the things. What do I have to now place? Well, the positive values were 2 and 5. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8. I want negative 1 right there. And again, starting from 0, moving out. 2, 3, 4, 5, 6, 7, negative 8. Boom, there it is. That is what, if I asked you to justify it, that's what the number line would look like. Recall, negative numbers are smaller, in quotes, the further they are away from 0. In other words, what looks like a bigger negative number is actually a smaller value. So something like negative 40 and negative 8. Even though negative 4, like 40 is bigger than 8, but negative 40 is more negative, and so we say that that thing has a smaller value. Even though that's conceptually a little bit weird for a lot of people. What about decimals and fractions? Let's talk about decimals here for a second. On the left, let's draw a vertical line here, and we're going to talk about fractions on the right. What if I was ordering those things?
You would convert them both to 1? Or you want to both convert them to the same.
What do you mean?
Like you would try to convert your fractions to a decimal.
Okay. So one way to deal with decimals is to convert to a fraction. If I've got a bunch of fractions, you could convert to a fraction. If I've got fractions, sure, you could convert to decimals. We'll look at doing that today. That's one option. We'll look at both of those options. If I had, let's talk about decimals here. Draw me a number line with the decimals. Boom, boom, boom. Let's throw a 0 down in the middle. Let's talk about a 1 over there, and we'll put a negative 1 over there. Here's a number for you. 0.2. Where would you place 0.2 on that number line? Yes.
After the 0.
After the 0. Yeah, there's a lot of ambiguity there. Quickly. Like when you say after, you're assuming we're moving left to right. So if after the 0 means over here somewhere?
Yeah.
Okay, where in there?
To the left.
Closer to the 0 or closer to the 1?
To the 0.
Okay, so you're suggesting that we would throw 0.2 in there. Okay. Where would I throw 0.8? Closer to the 1. Okay. So I'm hoping that most of you are comfortable with those ideas. I mean, we could do better than that, really. Like, we could have said something like, well, 0.2 is what fraction? Let's think about this. Yeah? Was that a hand? No, okay. 0.2 is what is a fraction? 2 over 10. Because there's a 2 in the 10th spot. And then sort of figure out Now, I mean, this is going to take us over to how we're going to deal with fractions and number lines here in a second. But if this is 2/10, how many gaps are there, or how many spaces are there going to be between 0 and 1 that I have to fill in here? Well, it's going to be 9 lines, which is going to give me 10 chunks. So 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. We can just count them out. Part of what I just did, though, is going to demonstrate a mistake I see all the time. If I list some of those numbers, 0.7, 0.8, 0.9, what comes next?
1.
Why am I listing this? Someone take a guess as to what mistake I see all the time. Yes, Dea.
0.10.
0.10. So 0.10 would look like this. This is the mistake I see all the time. And it has to do with the language that you use when you're reading the decimals. Actually, Miss Croissant did this last week too. When you guys were looking at decimals, she called this, I think she called it 0.10. Don't call this 0.10, because that's what leads to this mistake. This is 0.7, 0.8, 0.9. This is equivalent to what? 0.1. Because 0.1, and then you add a 0 to that, 0.10, that's the same thing. If we go back, this is just 0.1. So how could this be the same as this and this? And the short answer is it can't. And it connects to the language that you choose to use. I mean, calling this 0.7, 0.8, 0.9 does kind of work, but really, what is 0.7? It's
0.7.
or 0.700. That's the same problem that we're making. What would this be properly? If I was going to be really neurotic about the language that you used, this should be called what, Dea?
7/10.
7/10. There is a 7 in the tenths spot. And then that makes more sense. And you're not going to make the same mistake. 7/10, 8/10, 9/10. So then 1 is 10/10. And anything with the same or the same numerator as denominator is 1. 10/10 and 1 are the same thing. So this is wrong. Do not do this. Got to make sure you're really clear on how you number this. The other mistake that I see, and the reason that I bring up the number line is, okay, you guys placed 0.2 and 0.8 beautifully. If I were to put negative 0.2 on here, where would it be? A little bit behind 0. So again, you're assuming the left to rightness. When you say a little bit behind, you mean to the left? Negative 0.2. You're right, it's going to be to the left of 0 because this is the negatives, but where in this gap is negative 0.2 going to be?
Closer to the 0.
Closer to 0.
It should be closer to the 0. The same distance from 0 that 0.2 was, just to the left, right? Negative 0.2. Why am I bringing this up? What's the mistake you think I see? Or that you could think that I have seen, that I've been causing this to bring this up, yeah?
Would put it after the 1. Something like that.
They're going to put it, what I see all the time is they put it really close to this one, the negative 1. Because in your head, you picture the positive chunk, you say, okay, cool. So if that's 0, that's 1, that's going to be 0.2, it's going to be right close to there, just to the right of this value. And so, okay, wait, negative 0.2. Okay, so if 0.2 is just to the right, I'm going to go here and I'm going to go just to the right. This is the mistake I see all the time that you want to make sure you avoid. The negatives and the positives are mirrored with each other on either side of 0. So the negative 0.8 would be where?
Closer to the 1.
Be closer to the 1. No, it's not closer to the 1.
Wait,
Negative 0.8 is closer to the... I'm being really picky.
Negative.
There it is. I'm being really picky with the language that we use. Negative 0.8. Because the language that you use matters. And I know what you meant, but I wanted you to say it. Okay, so that's my spiel about decimals. Let's talk about fractions. You can convert to decimals. That is an option. We're going to look at that in a second. If you don't do that, what are some of your other options? There's 2 more.
greatest common factor?
Close. We're not going to common factor these things. We are going to common something else then.
What is it? Prime number?
Nope.
Denominator.
We want a common denominator these things. Common denominator. Which I will review momentarily. The other option, again, comes back to the number line. Let's throw down a number line here. All proper fractions fall between what two numbers? All proper fractions fall between what two numbers?
1 and 100?
Nope.
1, 0, and 1.
0 and 1. If you remember what a proper fraction is not mixed, and the numerator is smaller than the denominator. So a half, a quarter, a third. There's no whole number there. So all of those things are between 0 and 1. If I wanted to throw a fraction on a number line, yes, you could convert to decimals. That's an option. Decimals are nice and easy. Decimals are tenths or hundredths. Those are nice, easy conversions to make. What if we don't do that? What if I took something like 2/5 and I wanted to put that on a number line and I wanted to justify it without using the decimal representation of 2/5? How would you do that with the fractions? Hold on. You and Bosco have given me a lot. I want some of your other classmates to have a chance to say something. If not, then I'll come back to the two of you. How would I throw something like 2/5 on a number line? If you guys let Dea and Bosco talk the whole time about everything all the time, I'll put names on popsicle sticks and draw names. I've done this before. I had a Science 10 class that would never say anything. Looks like I'm making popsicle sticks. Dea, what's up?
Well, we could maybe change the denominator to 10 because that'd be easier.
Oh, you want to change it to tenths? Okay. How would I do that?
We times the 5 by 2 and times the 2 by 2.
Okay. To turn it into tenths, you multiply the 5 times 2 is 10. Whatever you do to the bottom, you have to do to the top. Just like simplifying fractions, so that's going to be 4/10. Bosco, and then just breaking this up into tenths. Bosco, did you have a different way to do it? You do the same thing. Okay. I want you guys to at least expose you to another option. Because you're not always going to be able to operate in tenths. Let's operate using the fraction the way it was. What does the denominator tell you of a fraction?
The spaces there should be.
Yes, the number of spaces there should be between two values. So that 5 there is, the denominator is the number of spaces on the number line. That's what that means is we're going to space out, without converting to tenths, we're going to space out 0 to 1 into 5 equal chunks as best we can. So if I'm going to use 5 equal chunks, what's that going to look like? So that if I have, there's 1 gap, 2 gaps, 3 gaps, 4, and 5. There's four lines in between because there's 1 chunk, 2 chunk, 3 chunks, 4 chunks, 5 chunks. Or you have 1 less line than you do the number in the denominator. I broke this up into 5 chunks. There's 4 lines because this then is going to be 1 of the 5 chunks, 2 of the 5 chunks, 3 of the 5 chunks, 4 of the 5 chunks, and then 1 is the 5 of 5. So if I'm placing 2/5 on there, that's kind of how you got to picture it. I want to break this thing up into 5 chunks using these 4 lines, and then that right there is my home on the number line. So I'll demonstrate what this looks like in another question. That's decimals and fractions, and we'll look at all of this today. So let's crank out some of these ones down here on the bottom. Negative 50 versus negative 2. Which of those two is smaller? Dea. Why?
Because it is further away from 0.
To the
Left.
left. Cool. That is the smaller value for that reason. Someone else. Negative 13 versus negative 14. Lydia. Negative 14 is smaller. For the same reason, but this one screws with students more because the numbers are closer together. And so they'll be like, oh yeah, negative 13 versus negative 14. Oh, 13 smaller. Boom, done. Having them further apart, for whatever reason, students seem to be able to like, oh yeah, negative 50. Obvious. But this one, for whatever reason, trips students up. Same thing with this one. Which one's smaller? Dea? Negative 2. Those are trivial. Let's look at the bottom three. 6/3 versus 4. Why? You're right, but why? Yeah, because 6/3, if that's a fraction, comparing fractions and whole numbers, I mean, can be tricky, and it's going to be tricky in a second. So let's convert that. 6/3 is 2. Because 6 divided by 3 is 2. So this, then, is going to be the smaller number. And I would like to express my appreciation for how you gave me your answer. Because, and this is something I want to draw everyone's attention to, because this is something you're going to do today. When I give you a value, two values, something like 6/3 versus 4, and I ask you to give me the smaller value, you're going to have to make some tweaks somewhere. And so what you said was that 6/3 is 2. When you go back then and give me your answer, I don't want the answer that you simplified it to. I want you to go back and give me the value that you started with, because that was the question that I asked. The question says, what is smaller, 6/3 or 4? And yes, 6/3 is 2, but I don't want you to say, oh, which one's smaller, 6/3 and 4, and your answer being 2. 2 is not one of the numbers I gave you to start, even though it was equivalent. So thank you for that. 6/3 is smaller than 4 for that reason. How about 2 and 6/4? How are we thinking about this, Dea?
It's gonna be 6/4.
It is going to be 6/4. Why?
So since we have improper, we're gonna convert it to a mixed.
Okay, you could do it that way. Sure. Mixed is going to be
1 point.
nope, no decimals.
1 and then 2/4.
Okay, and you can stop right there, because all the question asked is what number is smaller. So, and at this stage, it's easy to, even though this fraction, yes, you could reduce this fraction further. You don't have to. Because if this is 2, and this is a mixed number starting in 1, 2 is bigger than 1. So it doesn't matter what comes after this. 1 and 2/4, yes, Dea, you could have taken this one step further, and you were about to before I stopped you, to take this to 1.5. Oops. 1 and 1/2. But you only have to do as much work as is necessary to get the result you're looking for. You bet. In the other class, they did it the other way first. They said, oh, 6/4 is 3/2, and then 3/2 is 1 and 1/2. Doesn't matter which way you go. Yeah. Yeah. You also in the washroom? Oh, okay. At the end of the day, whatever method you choose, you can identify that 6/4 is the smaller one there. Last one, I got 2/3 and 4/7. I'm going to do this one two different ways. We're going to, because you guys gave me 2 ways, you gave me 3 ways to do it. Convert to a decimal, which we're going to do on the next page, common denominator, and a number line. Which one do you want me to demonstrate first? Dea wants the common denominator, so let's do the common denominator. If I give you multiple fractions, a way to analyze this is to find a common denominator. Which I'm not going to put out the whole word. I'm just going to call it a common denom. What is the rule for finding a common denominator? I don't dislike you guys because I'm not calling on the two of you, but I do want other classmates to have a chance to say things. Shall I just... Oh, Savia, was that a hand? Oh, sad. Especially since I know there's a whole chunk of you that are just like, I'm just going to shut up and work ahead. Which means you know the answer to this. How do you find a common... Oh, yeah, Quinn.
If you can't find any lower ones, you can always just multiply like 7 times 3.
Yes. So what is that called?
Cross
You're not reducing them. You're finding a common something. Who said that? A common multiple. Yes. It does not have to be the lowest. You just need to find me a common multiple. And the easiest way to find a common multiple between a bunch of numbers is just to multiply them together. So 3 times 7 is... So that's what I'm going to turn these fractions into. I'm going to go over 21, over 21. I multiplied 3 by 7. Whatever you do to the denominator, you also have to do to the numerator. So 7 times 2 is 14. And you multiplied 7 by 3 to get 21. So I'm going to multiply 4 by 3. 4 times 3 is?
12.
So which of those numbers is smaller, 2/3 or 4/7?
4 7.
4/7. Because if the denominators are the same, you just need to compare the numerators. 12 is smaller than 14, so 4/7 is the smaller fraction. Okay, that is the easier way to do this. I still want to demonstrate for you how to do this on a number line, because I am going to ask you today to place these fractions on a number line, and it's going to suck. But here we go. Number lines. I want the number line to be between, again, those are proper fractions, so where they're all going to land between 0 and 1. Up here when I demonstrated it, I was using fifths, so I needed to break the interval between 0 and 1 up into 5 chunks. Now I've got 2/3 and 4/7, so I have to do it twice. I want to break on the top, I'm going to break it up into one of these, and in the bottom, I'm going to break it up into the other one. The easier one to start with is which? Thirds or sevenths? Thirds are the easier one. And so what you need to do here is, I mean, you can use a ruler if you would like, but the thing that you're trying to picture is, I need to be able to break this gap, this line up into 3 relatively equal chunks. How many lines am I going to have to draw between 0 and 1 to break the line into 3 chunks? 2 lines. So I could basically put one there and there. There's a chunk, there's a chunk, there's a chunk. I have 3 chunks, which means each one of those chunks represents a third. So where am I putting 2/3 on that number line? 10. The line closer to the 1, you betcha. 2/3. Okay, where this gets painful is when you have to do it with the sevenths, because sevenths aren't particularly nice. But I need to be able to draw lines to break this up into 7 equal gaps. And so it's going to look something like this. There's a gap. There's a gap. There's a gap. 3, 4, 5, 6, 7. It's going to look something like that. And I've used a different color here to demonstrate that. But there's overlap. It's going to look gross. But this is what we need to be able to do. So this is going to be your 1/7, 2/7, 3/7, 4/7 is right there. And again, you can use a ruler if you'd like. I've got lots. But it's trying to picture what 7 gaps would look like on that number line. And that's the skill that you're going to spend a little bit of time practicing today. Questions about either one of these? Obviously, one of them is easier. The common denominator is the easier of the two, but you're going to have to do both. To practice, I'm going to give you 5, 6 minutes, 7 minutes, something like that. Not a lot of time. What I want you to do is I want you to flip the page and I want you to compare the fractions. Instead of giving me the smallest, I want you to give me the largest. I want you to do just the odds. If you insist on doing them all, do all of the odds first and then go back to the evens. But I want you to do all the odds first. I don't want you just to give me the answer. I want you to justify your answer. Give me proof on the page as to why the one that you've chosen is the larger of the two. I'll float around. Yeah, it'll float around. Help where needed. On your market, set, go. Give you a couple minutes. Take a look at this. Which of those, of every pair, you bet, which one is the larger? Justify it.
Oh yeah, you raised it.
Why don't I erase? Why you erase?
Because I prefer to do it home and don't have extra pages.
Well, then copy it over. Or you go back and watch it. But as long as you got a page, sure. If that's what you want to do, also, I'll do it. One of either Miller or Williams. Yeah. Pick which one is larger and give me justification using either the number line or common fractions. Let us know where we can assist. Yes. Right. Yes. Highest, yes, proof. Still right. Most to the right of 0. Oh, yeah. Ooh, those crunches. Yeah. Nice. At least there was something fun. Glad that you were at least doing something fun. Just the odds. Give me justification for your answer. Oh, and while you're going, let me show you one more thing. In the practice that I give you, if you ever see a page that looks like this, up at the top it'll say CUDA Software LLC. Anytime you see that, it means that if you continue flipping, because there's more questions I want you to do here, keep going. If you flip one more time, there will always be an answer key connected to pages that look like that. So once you've done them, go back and just double check that what you've done is correct. Any page that looks like this will have an answer key attached to it. Yes, they have. Yeah, 1 to 19 odds. Yes. Yeah, absolutely. Yeah, 1 to 19 odds. Sorry, there are 2 pages. 1 to 19 odds. If after you do the odds, you want to go break up the evens, fine. That's great. But I want everyone to do the odds first. And it's asking for the largest number this time, not the smallest. Yes. Okay. So, you got it. What's your question? Okay. So I give you 2 fractions. The question, so what the question is saying is, tell me which one of those is the bigger. The language. So low decimal, that's the nine. So you got. This is 1/3 of 1/2. And you're telling me that a third is bigger than a half. Why? Okay, so if I draw a line here. How big is half of the line? This would be half the line, right? That's a half. A third means I break the line up into 3 chunks. This chunk, this chunk. So this chunk right here would be 1/3. Which one of these lines? That. So using a number line, some is one way you can do this. Another way you can do this is say, okay, these are my fractions. 1/2 and 1/3. Instead of comparing these, because the denominators are different, it makes it difficult to visualize. What you can do is you can make them equivalent fractions, so the same kind of fraction, using the same denominator, called finding the common denominator. When you do that, if you say, okay, what number, or what is a common multiple of 2 and 3, or what is a number that 2 and 3 both multiply up to? No, they add to that. So you can also add 2. The multiples of 2 are 2, 4, 6, 8, 10, etc. The multiples of 3 are 3, 6, 9. But if we can keep the numbers small, it's easier. 6 shows up in both. So 1 times 2 gets you to 6. So whatever you do to the bottom, you also have to keep the fractions. This is 3 over 6. And to get to 6 over 3, we multiply by 2, whatever you do to the bottom, off. 2 over 6. Which one is bigger? The bottoms are the same, so it's up. This one has to be bigger because if they're both 6, this one's 3 6, this one's 2 6. So then 1/2 would be the bigger. That makes sense. You can either use the number line, or you can do this. For me or for in general? For me, I can do either one. For students, I think this is hard. Because in my experience, it is harder for students to visually, like, there's spatial reasoning. It's harder for most students. Most students would just be like, yeah, we'll find it. I just want to bring those numbers. Okay, cool. Find a common multiple. 2 and 3 both go to 6. Well, fine. Right. Let me try. Layla is back and William is back. Luis is the only one gone. Buy one more of those, Sandos, and then you can go. Okay, are we done? I want you to crank. I was gonna be 5 or 6 minutes to crank these up, so we're quick, and I want to do more stuff. Every time I stop talking, you guys don't need to turn on music. Crank them up. We're gonna move on. While some of you are working still, I want to give you a bit of a justification for why I'm even asking you to do this. A couple years ago, actually it's more than a couple years ago, it was back in the 90s when I was a kid. A&W thought they were going to be smart and compete with McDonald's. Big mistake, first attempt, but anyway. A&W and McDonald's competing. Obviously McDonald's, American company, A&W, Canadian company, they're like, okay, here's what we're going to do. A&W. We're going to make a 3rd pound burger. And we're going to charge a similar price to McDonald's fractional burger. What is the name of McDonald's fractional burger?
A quarter pounder.
The quarter pounder. Which one is a bigger burger?
A third.
The third pound, because a third is bigger than a quarter. And you think about, like, it's exactly this question. What's bigger, 1/3 or 1/4? Well, if I want to make these equivalent fractions, I'm going to make 3 and 4 both out of 12. Multiply by 4, multiply by 4 here, multiply by 3 here, multiply by 3 here. The quarter pound burger is 3/12. The third pound burger is 4/12. So for the same price, you're getting more burger. How do you think A&W did? How many people, forget the fact that I don't think A&W has a very good burger. Assuming the burgers are equal, Dan, you like A&W burgers? Okay, cool. So you go to A&W to order burgers? Is there a third pound burger on their menu?
Not anymore.
No.
Actually, maybe.
It tanked. Because the general public could not do this. Canadians looked at that and said, the quarter pound burger is obviously larger, I'm just going to keep going to McDonald's. And all it was is the comparing of fractions. A&W was too smart for their own good. They tried to say, we have more burger. But the general public did not make the conversion. Screwed it up, and A&W, their ad campaign for that third pound burger, tanked. You will not find a third pound burger at A&W.
I don't know, but it's.
Okay, that's, you and I will agree forever on that one. But we don't have In-N-Out here. That might giving you a true story of history, man. In-N-Out has nothing to do with it. Okay? Comparing fractions, there are actual applications to stuff like this. And the general public bombed it. Stuff like that happens all the time. You guys will learn about naming compounds in science class. Water has another chemical name.
Maybe 30.
Ugh. It was an April Fool's joke that got a bunch of people fired in Australia because of the different name for water, because people didn't. Simple. Okay, so here's what I want you to do. I gave you the answers to these questions. How do we feel about these? Are there any that anyone want me to do or demonstrate? Yes? Which one do you want me to do or demonstrate? Pick one. So you don't want me to do or demonstrate, or you do want me to do or demonstrate? I'm confused. I asked you is there any questions of the ones I assigned? I assigned you 10 questions. Are there any, and you got the answer key, so you're able to look back and you're able to see your answers. Is there any question of the 10 that I gave you that anyone would like to see me do? Number 5. Okay, so this guy here. The half or the 5/8. That's hard to see on the photocopy, so I'll make it clearer here on the screen. One of them is 1/2 and one of them is 5/8. So, Eve, would you like me to do a number line or would you like me to do common fractions? Would you like me to find the common denominators or would you like me to use a number line? How do you want me to do question 5? Okay, common denominator. So, for the common denominator, we need to find a number that 2 and 8 both go into. What is a number that 2 and 8 both go into? Quinn.
8.
They both go into 8. If for whatever reason that slipped your mind, just multiply the two of these things together. 2 times 8 is 16. We could use 16 if we wanted to. But Quinn's like, yeah, we can just use 8 because 8's even. 2 must go into it and 8 goes into itself. So, what do you multiply 2 by to get 8? And whatever you do to the denominator, Quinn, you have to do to the numerator. So 1 times 4 is 4. 2 times 4 is 8. So the half is 4/8. And the 5/8 is 5/8. So the question is, which one's bigger? Well, if the denominators are the same, we're just comparing numerators. 5/8 is bigger than a half. Because a half is only 4/8 and 5/8 is 5/8. You have more 8s. Does that make sense? Okay. That's all it is. Sure, you could go to 16. If we go up to 16, I have a half. That means I'm multiplying top and bottom by 8. On the 5/8, I'm multiplying top and bottom by 2. So that's going to be 8 16s, and that's going to be 10 16s. Same result. 5/8 is bigger because 10/16 is more than 8/16. There's more sixteenths there. It doesn't matter what the multiple is. You just have to find a multiple that you're comfortable with. Does that help clarify things at all, Eve? Okay. I mean, I'll get 17 too. The opposite is also true. If I look at a question like 17, everyone flip there if you haven't already. 17 is 36 over 81 versus 18 over 27. With something like this, sure, we could find a common multiple, but that would suck. What is a better way to approach a question like 17? You could reduce them both. 81 and 27, 36 and 18, all four of those numbers there are divisible by 9. Fun fact, they're also all divisible by 3. But we don't have to go all the way. You just have to reduce them a little bit. Let's divide them all by 9. Or sorry, no, that's not what I want to do. They aren't all divisible by 9. I want to take them down to ninths is what I want to do. So, to take 81 down to 9, I divide by 9, which means I have to divide the 36 by 9 as well. 27 is going to be divided by 3 to take us down to ninths, which means 18 also needs to be divided by 3. So the one on the left, the 36 81s, is going to become 4 ninths, and 1827 is going to become 6 ninths. So which one's bigger? 18/27 is the bigger one. You don't have to find a common. You could also divide your way down. Totally acceptable way to do this. There's a third way, and we talked about converting to decimals. So when you're ready, flip the page. Unless there's another question going once, twice, thrice sold. Okay, here we go. Let us look at converting fractions to decimals, because that is a skill that can help us here too. If I'm converting fractions to decimals, we're going to skip these first 9 for a second here. One way to do this is through the awful long division. That is one way to convert fractions to decimals. I'm going to change the question. I want to say, okay, I want to do 1/7. I want 1/7 as a decimal. So if you're going to use long division to figure out what the decimal value is, how do you set up your division statement? What number goes where inside long division?
The denominator goes on the outside.
The denominator always goes on the outside. The denominator is the thing you're dividing by. So the denominator goes outside, which means the numerator goes inside. Okay, cool. How many times does 7 go into 1? 0 times. Tosses 0. And if this was elementary school, you're doing long division, you want remainder things, you're done. There's nothing to do here. We don't want that. We want the decimal value. So for those of you who it's been a while, you're going to add a decimal, and then you're going to add a 0. You're going to put a decimal up in your answer. And now instead of 7 going into 1, we're going to talk about 7 going into 10. How many times does 7 go into 10? Once. 1 times 7 is 7. 10 minus 7 is 3. Add a 0. Keep her going. How many times does 7 go into 30?
4.
Because 4 times 7 is 28. Do the subtraction. 30 minus 28 is 2. Add a 0. Bring it down. How many times does 7 go into 20? Twice. 2 times 7 is 14. 20 minus 14 is 6. Add a 0. Bring it down. How many times does 7 go into 60?
8.
Because 8 times 7 is the number I hate. 56. Hate 56. Don't know why. Just do. 60 minus 56 is 4. Add a 0. Bring it down. How many times does 7 go into 40? Because 7 times 5 is 35. Do the subtraction. Add a 0. Bring it down. How many times does 7 go into 50? How many times does 7 go into 50? Because 7 times 7 is 49. 50 minus 41 is, 50 minus 49 is 1. Add a 0, bring it down. Oh, look! We're at 10 again.
Division.
Sorry?
It's an infinite division.
It's an infinite repeating division. Because it's going to go in once. 1 times 7 is 7. 3, add a 0, bring it down. 4, 28, or it's starting to repeat itself. So if I asked you what 1/7 was as a decimal, you have to divide until the thing starts to repeat. So we'd say that 1/7 is 0.142857 with a big line over all of it, which means that thing repeats. I used 7 as an example because sevenths are terrible numbers. There are, though, some nice fraction to decimal conversions that you should memorize if you haven't already. What are some fractions to decimals that you have memorized that are locked in your brain? 1/2. That's the one everyone always starts with. What is 1/2 as a decimal?
0.5.
0.5. If it's not locked in, lock it in. What's another one that you've got locked in? Yeah. Because we deal with quarters in dollars in currency. Canadian American currency deals with quarters. 1/4 is 0.25. So 2/4, well, that's 2/4 is the same as a half. So then 3/4, which is 0.5. So then 3/4 is 3/4, which is 75 cents, which is 0.75. You betcha. For my North American students, these are fractions that are always locked in. There's a couple more that you should absolutely have locked in. There's 3 more that for sure you should have locked in. Does anyone have more? Yes, Sam. The fifths. The fifths are good. We like the fifths. If you don't know the fifths or don't like the fifths, Sam, before you tell me what that is, what are the fifths related to? The tenths. Because if I multiply both of these by 2, 1/5 is going to be the same as 2/10. And the tenths are the basis for the decimal system. 2/10 is what as a decimal? 0.2. Because you have a 2 in the 10th spot. So then 1/5 is also going to be 0.2. So then 2/5 is going to be 0.4. It's twice as big as 1/5. 3/5 is going to be 0.6. 4/5 is 0.8. Not a hard one to lock in, which relates us to the tenths, also easy to lock in. There's one more easy one. Does anyone know the one more easy one?
6.
The 9th. 6 are trash. Don't talk to me about 6. We can figure out the 6 pretty easy. The 9ths. We love the 9ths. Because the 9ths also give us the... They're going to be repeating, but what other fraction group do the 9ths give us? Well, let's look at these. Okay, we'll do the 9ths, and you'll see what they relate to. What is 1/9? 0.1 repeating. I can do the long division to prove it to you, but 1/9 is 0.1 repeating. So then 2/9 is 0.2 repeating. So then 3/9 is 0.3 repeating. But look, what is 3/9? 3/9 is the same thing as
1/3.
1/3. So that means that 1/3 must also be 0.3 repeating. The 9ths, what I was asking you before, the 9ths also give us the thirds right away. Because if the 9ths are repeating, 3/9 reduces to 1/3, the decimal then has to be the same. 4/9 is 0.4 repeating. 5/9 is 0.5 repeating. 6/9 is 0.6 repeating, and 6/9 is the same as What can I reduce this to? 2 over 3. So then 2 over 3 must also be 0.6 repeating. These are the ones that you should absolutely have locked in. If you don't, you've got some memorization to do, and if you don't want to do that, then a whole bunch of you gentlemen, stop stealing each other's things. I want to see the front of your head, not the back of your head. Whole bunch of you have long division in your future, which I would do everything in my power to try and avoid. Memorizing 6 fractions is easier than constantly long dividing. Okay. With what little time we have left, I got one more task to do. Avec vous, here we go. We're going to convert some mixed fractions to decimals. I know I don't have a lot of time left. That's okay. We're going to use it. You have, gentlemen at the back table here, 2 options for converting mixed fractions to decimals. The first is the one we don't want to do. We can convert to from mixed fractions to improper fractions and long divide. Avoid this at all costs. It's an option. I would avoid it. It looks like this. 1 and 1 over 9 is what is a mixed fraction? Dea, 1 and 1 over 9 is what is not a mixed fraction, is an improper fraction?
10 over 9.
It's 10 over 9, because 9 times 1 is 9 plus 1 is 10. And so then if I'm doing the division, this is going to become 10 divided by 9. Goes in there once. Times 9 is 1.0, add a decimal. Bring the 0 down, goes in there once. 1 times 9 is, and it's going to go on forever. You're going to figure out that 1 and 1/9 is 1.1 repeating as you do the long division. Or what you can do is leave the whole number alone. 2 and 1/5 obviously is going to start with a 2. And then 1/5 is what as a decimal?
Oh.
So one of the ones I want you to lock in. 0.2. 1/5 is 0.2. So then 2 and 1/5 is going to be 2.2. You can lock some of those in. You don't have to do the division. Until I throw something screwy at you like this one. 4 and 5 over 2. This is terrible. We don't want 4 and 5 over 2. Because I've got a mixed number with an improper fraction. Bad. Bad to weed off. What would I do with something like this?
Make it all the mixed.
Make it all mixed. So the 4 is going to stay. What's 5 over 2 as a mixed fraction?
2 and 1 over 2.
So it's instead of having 4 and 5 over 2, it's going to become 4 plus 2 and 1 over 2. 2 goes into 5 twice with 1 left over. The denominator stays the same. Stuff that we were working on Friday. Which means that 4 and 5 over 2 is going to become 6 and 1 over 2, which is what is a decimal? What's a half as a decimal?
5.
And the 6 holes remain out front. Did you pack up my booklet just now, Bosco?
No.
Okay, you still have it there? Cool.
Yes.
So, your task in the 5 minutes that remain, using the skills that we've looked at, I have 6 numbers for you here. Fractions and integers. I want you to use whatever skills needed from the stuff that we've looked at today, things like common denominators, decimal conversion, or long division, to order those 6 numbers. If you want to use the number line first, give me the number line and then go up here and give me those numbers. I will tell you when to pack up. This is the last thing I want you to do for me today. If you don't get it done in the next 4 minutes, that one thing is your homework, and we'll start there tomorrow. On your mark, get set, go. I will tell you. I will give you some time to pack up.